and we will get started. Okay, so last week with the writing chemical equations, there was definitely people who reported back on the exit ticket and in chats being like, yo, that was a lot. So I want to review that just a little bit, and then go through the very last set of notes, the types of reaction notes, do a little bit of practice, go over like the final assignments that are due to me and what next week will look like, and then that'll be it. So writing chemical equations. This is the sort of thing that you can't really do if you're not feeling really good about writing chemical formulas. So I think people were doing a pretty decent job of recognizing reactants and products, but then in terms of actually putting together those compounds into the equation was the problem. So when I was looking at your quizzes scores, most of the missed questions on that chemical equations quizzes had a lot more to do with the fact that your formulas weren't right, not that things were in the wrong places. So looking through, because we didn't get tons of time to practice, when you are trying to write a chemical equation, I said the very first thing you always need to do is to try and figure out what compounds are present. So in this first equation here, this first sentence, what are some of the chemicals that you recognize are present here?
Chloride.
All right, so I've got lithium chloride here, and then aluminum chloride, and then what are the other things?
Nitrate.
All right,
Lithium.
and the two nitrates, so the aluminum nitrate and the lithium nitrate. So what word tells you that you are switching from reactants to products? Like where is the arrow here?
Producing.
Literally the word producing is telling me that I've got an arrow there. And then when you look at it, you've got, you know, some words that tell you that these things go together and that you have plus signs. And is always a plus sign. Reacts with is also a plus sign. And then what state of matter is mentioned for all of these things?
Is it a solid?
No, it's not a solid.
Dang it.
Is it a gas?
No.
What was the question?
Somebody left.
Is it a liquid?
No, it's the last one.
Is it aqueous?
It's aqueous. It's the solution, which is super annoying, but AQ, that's the way it is. So what we need to do then is the only thing you have to figure out is what are those formulas for the things we underlined. So you're going to need charges because all of these are ionic compounds. So from your periodic table, what's the charge of aluminum?
+3.
+3. Okay. So that means that aluminum is +3. It also means that this aluminum is +3. And so what is the lithium?
+1.
It's the +1, right? Okay, so that's a +1. All right, so then we have nitrate and chloride to figure out. Nitrate ending in that ATE that ATE is telling me that this is a polyatomic ion. So nitrate's charge, because that's one we don't always remember, happens to be a -1. And anybody remember what chloride, which stands for chlorine, is?
-1.
It is a -1. Okay. So all we have to do then is cross those charges and write things out. So aluminum and nitrate. Aluminum's 3 gets switched over to nitrate. Nitrate's 1 means you just write the Al. So it would be Al. Nitrate, which is a polyatomic ion, which means we're going to always put it in parentheses. So that's nitrate. And then you have its 3. So then you get its 3, and we said it's aqueous. All right, and then plus lithium chloride. If it's +1 and -1, those cancel out. So that's easy, LiCl. And then that's also,
Miss Baskin.
yeah.
Juan's in the waiting room.
Oh, I didn't recognize the name, so I didn't let him in. And then my arrow, and then aluminum chloride. So again, the +3 from aluminum goes over to the chlorine. Chlorine's 1 does nothing to aluminum, so AlCl3, also aqueous. And then the last one, the lithium nitrate, that +1, -1, those cancel out. So it would just be Li. And then NO3, you can put that last nitrate in parentheses or not. So it looked like most of the problem that people had with that last quizzes was trying to figure out the charges and writing it out into the formulas for the ionic. Because when people had problems like the second one was considerably easier for people because you had the prefixes that told you what you had going on. So there are 3 things to underline in the second one. What things should we underline in the second one? Elements and compounds mentioned in the second problem.
Alright,
Nitrogen monoxide,
nitrogen monoxide.
Yep, nitrogen monoxide,
nitrogen dioxide,
nitrogen dioxide, and
gas,
what gas though?
Oxygen.
oxygen.
The oxygen gas. Okay, so I see that I've got gas. Where's my arrow go?
Produce.
What word tells me I got a plus sign?
Burns in.
All right, the in here, definitely. And what do I do with this burns?
The triangle.
All right, on top of my arrow, I'm gonna have a triangle. So, nitrogen monoxide, that's an easy compound. Mono means how many? One. So that's just no. Nitrogen monoxide. Did they tell me any state of matter for nitrogen monoxide?
Nope.
No. So if there's nothing mentioned for it, then you don't have to put it. Okay? So plus, what do I need to remember about oxygen when I write it out?
Isn't it one of those like 7 things?
Yes,
the
it
D
is one
thing?
of the 7 that has to be written as a pair. So you've probably seen oxygen written as O2 a lot, but Don't know why, this is why. It exists as a pair. So O2 gas, I'm gonna put a G there because they told me it was. All right, and now my arrow with my triangle, because it doesn't matter where the word burns is, the triangle always goes over the arrow. And then nitrogen dioxide, di means how many?
2.
2. So I'm in O2, and then a gas. Okay. So that's just kind of a refresher for that. For today's stuff, we're going to be working with equations that are already written out instead of having to write them out first, because that's a little easier. But if somebody wants to take a picture of that before I clear the screen and move on, do that now. Okay, we good? Clearing it off. All right, moving on. Okay, so these notes, these apparently had a problem attaching the way I did the image or whatever. So if you got these from Google Classroom, great. If not, I'm gonna zoom in on each section so you could take a good picture and write them out later. But I'm gonna go ahead and switch over to my iPad. Okay, so these were going to be our last set of doodle notes. And in chemistry, we focus in on 5 different types of chemical reactions. This had 6, which is why you see canceled written across one that we're not going to focus on. But we're going to do them in order of, let's see here. We're going to do them in order of combustion, and then synthesis, and then decomposition, and then we'll do single replacement, and then we'll do double replacement. So that's the order that we're gonna work these through. And let me zoom in here. Okay. All right, that's a little too much. Okay, so combustion. The word combustion normally makes us think of stuff. So when something combusts, what do you think of?
Exploding. Or like
Exploding,
Explosion.
yeah. Most people think about exploding or burning or things like that. And largely that is the case. So in a combustion reaction, you have a compound that has carbon and hydrogen in it. And that carbon and hydrogen are going to react with oxygen. And that oxygen is always going to be as O2. And so it's this first compound that can change. You will see carbon and hydrogen, and sometimes even oxygen on there with all sorts of different numbers. But it's always going to be reacting with O2. And you're always going to make the exact same things in a combustion reaction. So they're actually pretty easy to spot, because you're always going to make carbon dioxide, and you're going to make water vapor, which is just a fancy way of saying steam, and you're going to make heat. So you normally think of a combustion reaction as exploding or burning or things, and that's partly because combustion reactions make heat. So the equation ends up always looking like carbon dioxide there, and it's going to make some water. And these are normally gases. And so if you look, this part of the reaction is always the same. The only thing that ever changes in a combustion reaction is what that very first thing is. So that's a combustion reaction. So take a snapshot if you need to, and then I'm going to move down to synthesis. And let me do another roll call because a lot of people came in. I still don't see Samaya, Trenton, Malachi.
I'm in here.
Oh, you are?
Yes, ma'am.
Okay. See, this is why I ask. Oh, are you listed as iPhone?
Yes, ma'am.
Okay, cool. Got you. So I still don't see Malachi, Kamaya, Charlie, or Tayon, Naila Brown. I see Naila Hall, Ayanla, Leander, Zora, Covenant, Janae, or Kamal. So, cool. All right. So, synthesis reaction. Synthesis reaction. What does it mean to synthesize something?
To make it small.
To make, right? Synthesize means we're making stuff. Okay. So in a synthesis reaction, you make complex things from simple things. So we're going to take simple compounds or elements, and we're going to combine them together to make a more complex thing. So for instance, if we take the simple element sodium and the simple element chlorine and we combine them together, we can make the more complex sodium chloride or table salt. So that's kind of what this looks like, taking two individual building blocks and sticking them together. So you get one thing that looked like this. That's kind of how we're focusing in here. And synthesis reactions are very easy to spot because there is only a single product. So there is one thing on the right, only one product. So that's how you are going to identify that you are looking at a synthesis reaction. So if you need to, take a snapshot of that before I move over to decomposition. All right. All right. Decomposition is the exact opposite, because what does it mean to decompose?
Break apart.
To break apart. Okay. So in a decomposition, it's when you have a compound breaks down into simpler ones. So this is the opposite of synthesis. So H2O2 is hydrogen peroxide. That's the stuff that you've got in your cabinet. If you have a cut or something, it's the stuff that bubbles. So hydrogen peroxide, when you pour it out, breaks down into water, which just rinses out the wound, and oxygen gas, which is what those bubbles are. And then those bubbles actually help kill off any bacteria. So this is the reaction for hydrogen peroxide. And you will notice here that we are focusing in on only a single reactant. All right, so you've got one reactant. So one thing on the left. in case you remember which, or forget which side reactant is on. It's on the left. So you're starting off with only one thing and it's breaking apart into multiple things. So this little compound thing here, it's going to break apart into its two different things. So decomposition, if you just remember what it means to decompose, it's easy to remember that it's one thing breaking apart into smaller things. So if you need to take a picture and move down to single displacement. Okay, so single displacement. I don't remember which term the video for this week uses, but you will see displacement and replacement used interchangeably because they mean the same thing. So when you replace something, you switch it out. So in a single displacement or a single replacement, the thing we are replacing is an individual element. So single here refers to an element as opposed to a compound. So in a single displacement or replacement reaction occurs when a pure element switches places with another element inside a compound. So you kind of have to know who does the switching. There we go. You kind of have to know who does the switching. So in general, metals switch with other metals, and non-metals switch with other non-metals. Which should make sense. Like if you're going to switch places, you want to switch places with something you're already like. So in this instance, magnesium, it's by itself. That is not in a compound. It's only one capital letter here. So this is an element. All right, I can say that's an E. Here, this is HCl. That is not an I. So I've got two capital letters here, so I know that's a compound. And so my metal element is going to switch places with the metal that is in this thing. Now, there's not technically a metal in there, but hydrogen is on the left-hand side, so it's going to switch places. So magnesium is going to switch places with the hydrogen, and the hydrogen is going to get bumped out on its own. So when we write hydrogen by itself, it is H2, because it's one of those 7. And then magnesium is going to go with the chlorine. It stays in front because metals are always in front. But its correct formula there is MgCl2. And so what ends up happening is that you have an element on each side and a compound on each side. So you can recognize that you have a single displacement by looking for this element compound pattern occurring on each side. So you're going to get something that looks like this. And that's what you got for a single displacement. And then take a picture if you need to. We'll switch to the double, because the double replacement is going to look almost exactly like the single. Okay, so for the double displacement or the double replacement, here double refers to compound. So we have two things switching. So you essentially have a compound and a compound. And what you are going to do is you are going to take the front half of each compound and they are going to switch places. So the way we write this out is in a double replacement or displacement reaction occurs when the cations, which is just a fancy way of saying the front half of the two compounds switch places. So the hydrogen is now going to go with the NO2 and the Ag is going to go with the Cl. So if it starts in front, it stays in front. Starts in front. Stays in front. So my Ag started in front, so it stays in front, and it's now going to go with the chlorine. And my hydrogen started in front, so it stays in front, and the back half gets written behind it there. So, and then trapezoid with, oh, sweet Jesus. I'm going to draw that thing. Oh, that's not bad. Okay. So, for the double replacement reaction, I have compounds all the way across. It is nothing but compounds. A double replacement reaction is nothing but compounds. It's the only one that is nothing but compounds. That does make it easier to spot. So make sure you get that. Take a picture if you need to, because I'm going to switch back to the slide deck for the practice. Okay. So for these practice, yes?
Can you go back to the last slide?
Yes.
Thank you.
Uh-huh. Okay. So for these practice, what I want to do is kind of look at general patterns. That's the best way to look at these things. So some patterns are easier to spot than others. Synthesis and decomposition are by far the easiest reactions to spot because they're the only reactions that have single things on one side. So again, a synthesis is going to be one product, and a decomposition is going to be one reactant. So in these, let's, out of this list, let's try and do that first. So reactant versus, okay. So which of these reactions looks like it only has one product in it? The first one, the second one, the third, the fourth, or the fifth? Only one product.
The second one.
The second. All right, so I only have one thing on this right-hand side. This second reaction is what we refer to as a synthesis. Okay, yeah, all those people who have to go to AP World, go for it because your exam is tomorrow and good luck and God bless. So let's see here. Okay, so if that's the one that has the synthesis with the one product, which reaction only has one reactant? Which one is the opposite of that synthesis?
The first one.
The first one, the third, the fourth, or the fifth?
The first one.
The first. All right.
Uh,
So I've got one thing on the left-hand side. So that makes this a decomposition. Okay. So for the others, my combustion reaction, remember, for my combustion reaction, I am looking for something that has some carbon-containing compound plus oxygen making CO2 and water. So which one of those reactions seems to follow that sort of pattern? The third, the fourth, or the fifth?
Fourth.
The fourth one, okay? So I can see right here, this O2 making CO2 plus H2O. That's what you look for a combustion. All right, so that's a combustion. So that means my remaining two reactions are either a single or a double replacement. So the easiest way to figure these out is to identify each thing as either an element or a compound. So looking at reaction 3, is this first thing an element or a compound? The Na2SO4.
Compound.
Compound.
That's a compound. I can tell it's a compound because it's got all these capital letters. That makes it easy. All right, what about the next thing? AlCl3.
Compound. Compound.
Compound. All right, capital A and capital C. So I already know if I'm starting off with a compound, then I'm going to guess that over here I also have, look at all those capital letters. So that's a compound. Look at all these capital letters. That's a compound. I have nothing but compounds. So this is a double replacement because it is all compounds. All right. So the bottom reaction, when I see this individual capital letter by itself, the Li, that's telling me that's an element. And then the capital M and the capital B, those multiple capital letters are telling me that's a compound. Multiple capital letters, so that's a compound. Only one capital letter, that's an element. So if I have an element and a compound on each side, that's how I recognize the single replacement. All right, so it's an element and a compound on each side. So I would, if I were you, I would take a picture of this screen because this is going to be helpful to reference when you are doing the practice and the quizzes. Everybody got it so I can clear it? Okay. So this is your last batch of assignments. So your last video is the types of chemical reactions. I've already had about a dozen people do it. It's pretty fast. It's going to look exactly like these notes. There's just not that many ways to talk about types of chemical reactions. Your exit tickets on the next screen. Then there's two portions of your practice and application grade. The first one is, it's called a types of reaction concept builder. And it's a thing where basically it's a way to let you practice with multiple different types of things before you do the quizzes. So if you do the concept builder and you do it as much as you want, That's a completion grade, but you have to take a picture of the final screen showing what you did on the practice and then attach it to Google Classroom to the assignment. Some people had problems attaching it to the assignment. If that's the case, you can either email it to me or send it to me in a remind message, and I'm taking notes so that you get credit for it. But you should do that concept builder first and then do the quizzes. So there's 20 questions on the quizzes, and the quizzes is basically identifying, it's 20 questions of here's a reaction, which type of reaction is it? Is essentially what it is. So you'll want to do that concept builder first. So the links for the concept builder and the quizzes are both in Google Classroom. And that's it. So that is your exit ticket. I'll drop it into the chat so you can do a direct click on it. bit.ly/Chem5X. So there that is.
Thank you.
And then, so this stuff is due Sunday night. I am not holding class next week. After I enter grades, you can look for emails from me on Tuesday with any remaining work you might be missing. And if you are not missing any work, then that email will simply say, this is your term 4 grade, this is your overall course grade. So that is my goal for Tuesday of next week, so that you can get done with me early, because I know lots of your classes are doing like larger project stuff. So in theory, if you had time the rest of today, you could knock out that concept builder and the quizzes today and be done. That's it. So I will stop recording, and then you are welcome to